Thank you for coming to the Berkeley Springs Transition Talks. What I'd like to do is talk to you a little bit about the world that seems to be emerging here. And let me start by saying this is a talk about patterns. This is a talk about patterns because the only way any of us make sense out of anything is by pattern recognition. You understand that? If you go into a room and things don't make sense, what you mostly do is shut it off and you don't look at it. But you can only make sense out of patterns that you relate to what you've known and seen and made sense of in the past. And so everything is about pattern recognition and the ability to try to see patterns one place or another. That's why science has breakthroughs, because they see patterns in relationships to things that they've known in the past in one way or another. And so pattern recognition is at the fundamental base of sense making. I've spent a bunch of time trying to think about working with the computer scientists about how you do sense making and what the process is, and it's all about trying to extract patterns wherever you do in one place or another. And so this is a talk about patterns, because these patterns run throughout all of what we do, and the problem is if you don't see the patterns, then it doesn't make sense, right? And so if you can start to see how the patterns all tie together, then it starts to make sense in a coherent way. And evolutionary biologists have this concept that they call punctuated equilibrium. And what they say is that there's long periods of time where there's essentially consistency, and then you have this punctuation in the equilibrium, and it jumps up to a new level, and then it goes equilibrium for a while, and then it punches up, jumps up again. And you know, the way they talk about it, and the way we seem to understand it, is that single cellular life showed up about 3.5 billion years ago, and multiple cellular life was about 1 billion years ago, and then vertebrates were 500 million years ago, and mammals were 50 million years ago. And this is obviously biological change, biological shifts. And as you can see, the last two stages of this, it starts to take on a pattern. And the pattern is that the succeeding one is 1/10 of the length of the preceding one, right? It's 50 million years, the one before is 500 million years. And so then it goes from mammals, and then it goes to early humans, which was about 5 million years ago. So there it is, it's right in there again. And then the change starts to go, it comes up to Homo sapiens, and then it starts to go from biological change to essentially kind of cultural change. And that's just the basis on which almost everybody who looks at these kind of things comes to the conclusion that these big transitions start to then hinge around them. First of all, they were hunters and gatherers. And then there was this dramatic kind of shift where they became active farmers, right? Organized agriculture. And then there was this long period of time from 10,000 years ago to 5,000 years ago when it was just kind of agriculture and there were no cities and towns. And then whatever happened, the thing turned, and then human beings began moving into cities and towns. And by the way, that's when the first written language started to show up, because it had to do with commerce and how to keep track of records of commercial activities. And then from cities and towns, then 500 years ago, Gutenberg invented his movable type. And what that did is fundamentally change the way human beings communicated information, right? Before that, all they could do was talk to each other, and they could sit around and wait for some monk to scribble out, copy things one at a time. And by the way, they couldn't read, and so they couldn't get it, and so on. And they kind of kept it only for the priests, so that they. But for the 300 years after Gutenberg invented the movable type, it fundamentally changed the way information was distributed. It destroyed the structures, the social and the legal and other kind of structures throughout Europe because remember, the Catholic Church ran it all before Gutenberg did his thing. And then Gutenberg shows up, does this movable type. Now anybody can have a Bible, right? And 100 years later, man, they've just been whipped out of Northern Europe. And there's all kinds of things that have happened that they really never could have anticipated, because it changed the way human beings communicate. And then the industrialization, 50, then what's the progression? It goes from 5,500 to 50, right? And so 50 years ago, you say to yourself, what happened? Well, the computer, and ultimately the internet. That was the beginning of what ultimately became the internet. And that, again, changes fundamentally how communication happens. It just amps it all up, makes it, proliferates it, makes it easier, it just does amazing kind of things. And then what's the next one after that? 5, right? And then it gets, and so what you've got here is an exponential relationship. What we are doing is riding the wave in the most extraordinary period of time on this planet. And that amazing kind of change is happening in very short periods of time. But that's the pattern, and that's the pattern you've got to keep in your mind, because then the question becomes, how do you ride that wave and where is it going? And that's what we want to talk a little bit about here. So we're experiencing nothing less than a rapid evolutionary jump in our species. Nobody here really knows what that means. Nobody here has ever lived through one of those before. Nobody here has the tools, the experience, the books, the libraries, whatever it is, to try to make sense out of all of that. And so we're all kind of together in this amazing kind of transition into a new world, and it is unlike anything that's ever happened before in life. Last year, I kind of gathered up a list of what a bunch of kind of unconventional kind of sources all said about what was going on, and Cryon said that this transition is a 36-year transition, and 2013 last year or so, it was about past the peak. 2012 was about the middle of it. And so the transition, it doesn't just happen overnight. You don't wake up and it's a whole new world. It goes over a period of time. Ken Carey says it's a generation, about 22 years or something like that. Others say kind of it started in 1989 and it's kind of end in 2025. But I mean, we're into this amazing kind of transition. One thing I should tell you about in those stair-step kind of punctuations is that not only do the long periods of time get shorter by a factor of 10, but the transition times shorten up. And so where you might have had 300 years for the Gutenberg and the movable type to kind of reorganize the world, that you could probably do a 30-year kind of thing on top of the computers and the internet. And then you could probably do a 3-year one, I don't know what it is, but it's a relationship like that transitions get shorter and shorter and shorter. And at the same time, in each succeeding era, the amount of information and the amount of complexity expands by about 8 or 9 times. And so you get a huge explosion of information and knowledge and other things that follow this, but they're coming faster and faster, and the transition is happening quicker and quicker. And so that's what we're in the middle of, and that's what's happening. And so this 36-year period is the transition into this whole new kind of world. And let me tell you, you cannot, from a succeeding era, make any sense of the preceding era, what the succeeding era is going to look like. You can't sit in the middle of all single cellular organisms and figure out that on the other side of the wall is multiple cellular life, because there just ain't none, Everywhere you look, there's just single cellular organisms, and you can't get over that thing. And the same thing, a day before Gutenberg did his movable type, nobody would have been able to figure out that the whole world was going to change on the other side because of this new capability. And that's a fundamental kind of characteristic of these kind of transitions, because we're into a space where, for the first time, we, as the principal kind of actors in this process, can see that it's happening. We've got stuff like this and information and charts and things, and we can see that it's coming, which nobody else could ever see before. But at the same time, as you try to look down there, what you understand is that this world down here, which is really different from here, is just necessarily going to operate in a really, really different way. And that's the fun part of it, is to try to figure out what impact that may be. So the old systems collapse, implode, become dysfunctional, and the new ones emerge in that whole kind of process. Cryon says, this is the lifetime that'll make the difference. This is the extraordinary kind of period of time that we're all here to make a huge kind of difference. So the question is, if it's the biggest shift of all, so what in the world? Where are we going, and what's it going to look like? Well, I tell you where I go. I go down to first principles, and I say, tell me how this kind of reality that we're in operates in the most fundamental way, and then let's build it on top of that. That's because, I mean, anything else that's downstream from the most fundamental kind of concepts and ideas are all derivative, and they all have humans and all kinds of things in them, and ideas and politics and any number of others. That's the problem with the Bible, by the way. And so what you want to do is get down to first principles. And the most fundamental description of how this reality works comes from a guy named Hermes Trismegistus. Now, Hermes was one of these extraordinary people that was supposedly lived 300 years or more. He was alive supposedly during the Egyptian period, where he had a name called Thoth. And then later on, he had the name Hermes Trismegistus. I don't think anybody knows what he looked like, but if you want an idea about what he looks like, with almost naked, that's him. And that's what somebody thought anyway. And but Hermes was a really bright guy. And Hermes, near the beginning of not this century, but the last century, the 1900s, three what they call it initiates, individuals who were students of Hermes' work, wrote a book called The Kabbalion. And the Kabbalion is extraordinarily powerful and profound. And the Kabbalion says all of these hermetic principles. And Hermes said, for instance, that everything is mental. All of the reality, everything that we experience here is all mental. He said that there's a principle of correspondence, that everything relates to everything else. It corresponds to everything else. He said that everything vibrates. Everything vibrates. Nothing is solid, no matter. And if you look in science, and as big as you go, as small as you go, what you find out that is true. What it also says is that there was a principle of polarity. What he says is that that things go from one side to another, and they change, and nothing is just what it seems to be. There's always an opposite to the thing. The example a lot of people use is temperature. I mean, what is hot? You don't know what hot is. Hot is all relative, and in any given period, if it's something that's hot, then it's kind of cooler on one side, not. So there's always kind of polarity involved in that. There's the principle of rhythm that says that everything in our life goes out and ebbs and flows, out and back and out and back. Sometimes little ones, sometimes big ones, but there's this constant kind of rhythmic, cyclical kind of nature to how this reality works. It says there's always cause and effect. Everything that happens has got some predecessor. Anyway, something that happened before. And and then there's the principle of gender that says that almost everything has a masculine and a feminine aspect to it all. And I mean, and if you internalize those kind of notions, what you've got is a framework for understanding reality and how this all works that is just really amazingly profound and can be expanded into and extended into all kinds of areas. But I want to take just one of them, the correspondence one. The correspondence principle, you've all heard of. You've heard of as above, so below, as below, so above. And that's the articulation of the principle of correspondence. And what it essentially says that everything is the same as everything else in more or less. That there are all of these common kind of relationships that have, no matter how high or how low that you go, and that, in fact, if you can start to get your arms around some of those kinds of notions, that they're projectable, that they're you can extrapolate into other kind of space. It gives you the most fundamental kind of notion about how other things work if you can isolate in one place about how one thing works. Because if you can do microbes, let me tell you, you can ultimately take it up to astronomy and how planets and stars and things work. And I'm not going to go there today, but I promise you that you can do it. I've read some stuff about it. And so the idea is about fractals. You know what a fractal is? I'll show you here in a picture in a minute. But the fractals are this idea that within there's just kind of one thing, and then every component part of it has the same elements as the one thing. And here's a hologram, right? You seen a hologram before? So it's got these funny. You get some of these funny pictures, and so you have one picture, and you can cut it in half, and it still has two stars, just like that one. And if you could just cut off a corner of it, it still has stars. So every and fractals, and that are these embedded relationships. And what I want to do is walk you through for just a minute and a half of this video that about the Mandelbrot figure. The Mandelbrot set is, have you ever seen this thing that looks like that? This is generated from a very simple formula, and it's just z to the squared. It's just three things. And what it does is this extraordinary kind of replication of the same pattern. So there you have the big pattern, and then you go down, and this one's 50 times smaller than the big one. And they are not completely, this is important, they're not completely the same as the big one, but they're really a whole lot like it. So that one there, see, it starts to look the same way, but it's not quite the same. It's 76,000 times smaller. You get all these copies, different places in it. And so what you get is this replication from very small to very high with the same basic kind of notions. And they have, they end up being different colors. And the boundaries just don't have different shapes, but they are very similar to nature. And this is where a lot of the kind of notions about how nature comes from practical geometry is what this calls. So you work yourself down there, and it looks very floral, and then rivers that might have lakes, and you see a whole lot of natural patterns in here that can be part of, that come very naturally from very simple kinds of mathematical relationships, rivers and lakes, and then galaxies and waterfalls and other such things. So what mathematicians have found is that, in fact, those relationships, as above, so below, as below, so above, can be generated in very simple kind of math that generate this extraordinary complexity that replicates itself and has the same kind of patterns and the same relationships wherever you go within the system. So now you go to so now you start to say, okay, so how do scientists say that the natural ecosystems work? Buzz Holling is a very well-known ecologist, and he is one of the authors of a thing called panarchy theory. Pan, in this case, is talking about Pan, the nature, the god of nature. And anarchy is about government. And so it's kind of how nature governs itself is what this is about. And what he has done is studied at great detail and for many decades how natural ecosystems work. And in particular things like forests, and how's the life cycle of a forest, of a complex, interactive kind of system, how does that work? And what he has figured out, and you need to remember these patterns because this is all about patterns. What he has figured out is that there is this kind of process that goes from exploitation to conservation to release and then reorganization. if you map this on a 2x2 grid of potential going to the north and connectedness going to the east, what you can see is that, I mean, think of it in terms of if you cut down all the trees on a piece of land, that's exploitation. And then over time they grow in and they regrow and you get conservation. And then after a while, then let's say that there was a disaster or something that happened and there was a reorganization and there's a release, and then they reorganize themselves coming around. And so there's this constant kind of relationship. It gets itself back together again. You grow some new trees, it gets reorganized, and then people go to cut them down again. Like some of my friends that are in this room. Yeah. Anyway, so you have this relationship, and it's really interesting because the basic relationship is fractal, and it goes up and down and below. And what Holling says is that one never exists by itself. There are smaller, faster ones underneath that support it, and there are larger, slower ones up above. So if you had, for instance, a forest, and you were looking at that as the system, underneath it would be the microbes and other kind of things, which operate in the same kind of way, but they're faster and the metabolism is quicker. And up above, there's a kind of planetary, biochemical kind of relationships that are kind of slow. You might say, for instance, the climate would be a slower one, perhaps, I don't know, depending upon what, but whatever it is, you can see that it's all interconnected and they're all nested, they're all related to each other. It's horribly complex, amazingly complex, but there are all these direct interconnections. And so the important thing is that these different systems, which all are related to each other, it's critically important that you don't have any of them that all fail at the same time, because then you get a catastrophic failure that cascades through the whole system, and then it's no way in which the thing can rebuild itself, because it has none of the memory that's left over from the large scale things that has a long time cycle. It tells the system how to keep going. And it doesn't have all the small innovation and small and fast kind of things, they call it revolt, that drive themselves into the system. And you could think of, for instance, the internet and some of that being kind of the fast one that goes really fast, and then here's the way we all live, and up above is, I don't know, global climate or some other kind of thing. But you can see that it all fits and it all works together. And so if you got this kind of a system that works like this, then he's been studying this for 4 years or something like that. And what Holling says, he thinks that we're on the verge of some kind of a systemic crisis, that the whole thing's going to come apart. And he says, why? Because adaptive cycles can be nested together from small to large, and they, just like I described to you, and build this complicated interdependent anarchy. And then rapidly rising connectivity within global systems, that's the internet. Rapidly rising connectivity, both economic and technological, increases the risk of a deep collapse. He has looked at the natural systems, and what he has done, and this is important, is he's brought those principles up to the human kind of systems, and he starts to say, if you look below and how the things work below, you can raise them up to the human system, and you can see how that all works, and you can predict the way that the human things are going to operate. Because then he says, the third reason is the rise of mega-terrorism. And I thought, come on, man, 60% of the people in this country believe 9/11 was a put-up job, and if you bought into that whole idea that it was really real, then you can get to that point of view. But otherwise, if you're relatively sophisticated, and you've done your homework, by the way, and done your homework on this, then what you figure out is that that's not an issue. And so the likelihood that there's going to be a collapse of the system, I would argue, is less than he thinks. But nevertheless, what you've got is a pulse, a special transformation, something that could happen that could drive this into this new era that's coming downstream, and that is relatively predictable. And what he's saying is that humankind has experienced 3 or 4 of those in the past. You know, like I said, from hunter-gatherers to agriculture, the industrial and communications revolution, and another pulse is going to begin. So a guy who spends his time studying forests have come to the conclusion that there's large-scale kind of transition about to come in terms of human systems, as below, so above. And he's come, and so you say, so what? So what's coming? Is larger, slower systems could be a cosmic cycle influence. This is the weirdness in me. So larger, slower systems, the upper one, right? It's driving the one that we're all in. How do we know? It could be influenced by who knows who, operating on an unknown but well-established rules. And the principle is that someone has preceded it. What that means is that if you believe that what we're experiencing and what we're living in is all random, and it's all just kind of ad hocery, and we're just kind of kind of making our way through it, then you got no framework to either make sense or have hope, for that matter, because you don't know where it's going, and all you do is read the news. It's all going into the toilet. That's where it's going. But if you thought that this experience, human experiment that we're part of, is part of some larger plan that is orchestrated, has happened before, maybe thousands of times, and there's a plan about how planets and species like ours evolve, and that we're just in the middle of it, and it's being orchestrated and by who knows who, then it gives you all kinds of hope about that there's some direction to all of this, and it's part of a larger kind of notion. And so I think that that's part of what you get out of this idea of panarchy. And the present pulse could be another revolution in communication. I'm pretty convinced that somewhere in the not too distant future there's another Google. Only this Google is Google times 10. And what it does is allow us to communicate. This is all about communication, this kind of thing. And it'll allow us, whether it's projection holography or whatever it turns out to, I don't know what it's going to be, but what it will do is allow us to communicate with other human beings with far more fidelity and far more bandwidth than you can do right now. And what it'll do is allow us to increasingly replicate the otherwise physical kind of situation of sitting in front of somebody like Gareth and looking in his eyes and being able to talk to him. And if you can do that widespread way across this planet, everything changes again, because it's the equivalent of publishing books, and it's the equivalent of the internet. It just changes the way everybody thinks and how it all works. I'd say that our ability to transcend may be encouraged or influenced by smaller cyclical systems. So if you move yourself down on the underlying system, then you could talk about plant intelligence, and you could talk about elementals, the spirits that run around and all that kind of stuff. And so what you're starting to do is get into a framework to be able to make sense out of all this and how it happens going forward. So then you get to a guy like Stephen Herod Buhner. Stephen Herod Buhner calls himself a earth poet. This is a man who's written a couple of books that I've read, one called Secret Teachings of Plants and Plant Intelligence, that Heidi sent me into this. And these are the most extraordinary and beautiful books, both in terms of how they're designed, and obviously they're beautiful books, but the writing is just amazing. And they have such extraordinary depth and richness of information, profound stuff. And Stephen Buhner takes this basic notion of the ecosystems, and he starts to expand it out and starts to explain how this stuff works. And he says if you go out in the middle of the ocean, and you go down to the bottom of the ocean, and you take a section out of the, and you look down layer by layer underneath that, there's a place down here about 500 to 500 feet below the water where there's different layers of basalt. And these basalt seams are made up of bacterial life. And these seams run all around the whole planet. The whole planet is covered by this seam. And it is the largest single unified ecosystem, and it's the foundation for all of the life that exists on this planet. And if you go down to this you go to that biology and you start to talk about those kinds of the bacteria and the other things that are part of that, what you find out is some very, very interesting things. What they find out is the bacteria, by the people who have now studied them, are not only intelligent, but they possess sophisticated language and highly developed social capacities. And they're not really that much different than we are. I mean, you think of them as you should wash your hands, right, so you don't get sick and all that. No. These guys are really bright. They're really small, but they're really bright, you know. They communicate in languages. They change their genetics depending upon the different situation they're in. They have a sense of self. You know, a bacterium knows who he is, or she is, or whatever it is. You know, they share common chemical cues. They talk to each other. They have dialogues back and forth. They recognize their colonies and their kin and the other ones on the other side. They have intentional behavior. They do certain things in different kinds of situations. They alter their colony structure for certain situations. You know, if they are threatened by something or some other things, they reorganize themselves like almost like a military thing. I mean, these guys are really smart. They recognize and they identify other colonies. I mean, think about what it requires to be able to do that, to know who you guys are and so on. They remember, they learn things, and they pass them down to their progeny. They get, you know, generation after generation. They're like human. 40 years of experience. James Shapiro from the University of Chicago said 40 years of experience has taught me that they possess many cognitive, computational, evolutionary capabilities unimaginable in the first decades of the 60th century. He said, even the smallest cells are sentient beings. God, you got that? These guys are alive and they're smart. I mean, and they're everywhere. I mean, they're everything, because you know, they're what we all are come from. Everything on this planet is built up from these. And they're all in there talking to each other, carrying on, and doing all of the kind of stuff that they do. And it's really kind of amazing. Bacterial communication processes are more powerful than human technology. You know, you think about our internet and all of the ways and radios and they're better. Right now, they're better. And so it's just pretty extraordinary. So now that's what's underneath everything. And then if you take it up a little bit and you say, okay, so if that's what's supporting everything, then what's the next level up? Well, they're plants. And you say, well, wait, if all those guys are so smart, then what about the plants that are all the derivatives and live with them? Well, Charles Darwin, in a little-known book, it's one of the last books that he wrote profoundly about all of this. And he said, it's hardly an exaggeration to say that the tip of the radicle, which is the end of the root, is endowed with sensitivity, and it has the power of directing movements of the adjoining parts and acts like the brain of one of the lower animals, the brain being seated within the anterior end of the body, receiving impressions from sense organs and directing several movements. What it says is the brain is the roots of a plant. And if you want to understand how a plant root operates, the brain is down below. And the brain has got all these sensor systems, that just like the neurons in our brain, that are in the root system, and they're all out there moving and communicating and talking, and by the way, talking to everybody, doing all kinds of things. And it then controls and provides direction to the larger system. And so you have a literal kind of functioning brain-like role that exists in all of these plants. So if you go to a beautiful kind of garden like this, what you find out is that all of these plants, they forage for limited resources above and below ground. Follow that? I mean, they look for and find, they make decisions, they check, they figure out all these kinds, it's intelligent stuff. They compute their circumstances. They use sophisticated cost-benefit analysis to make decisions about what they're going to do and where they're going to, should I do this or should this? Take defined actions to mitigate and control environmental insults, so if somebody comes and stomps on them, they know what to do. They take defined kind of reactions. They are capable of refined recognition of themselves and their non-selves. I mean, they know who's outside and who is out there and all this kind of stuff. I mean, they're pretty smart. They exhibit territorial behavior. I mean, they know their part and they know the other guy's part, and they have sophisticated as animals, only they're much slower. Because you see what they are one of those higher, slower systems that operates on a slower kind of process, and that they're not running around very fast, but they are adapting and they have the same sophistication and the same intelligence and the same kind of things that are in humans and also in the bacterium underneath them. Bacteria. They have signaling information and processing apparatus, and they interact with other plants and fungi and nematodes and bacteria and insects and predatory. I mean, they're managing all this kind of stuff all at the same time. They can recognize you and read your mind. The plants know who you are when you walk into the room, and they know what you're thinking before you decide to do it. If you want to burn their leaf or do something like that, if you wire them up and look at their metabolism and the energy, it just goes, and it's crazy. And they know, and they can read your mind down the hall if you're thinking about them. It's just amazing. I mean, the number one lie detector technician for the CIA went off and wired up some plants to figure out, and figured all that out. And it just blew his mind, because he said, man, they knew me when I walked into the room, and they knew other people, and they knew if somebody had heard them before, a week later came in, anyway. They speak with auditory signals. It's hard to hear, but they talk to each other. They choose optimum responses for many options. They can determine great specificity what touches them. They know the difference between a human or something else touching their leaf and a drop of rain hitting the leaf. A drop of rain will hit the leaf and it won't do anything, and if you touch the leaf, then it'll move in some cases. I mean, they know. They determine meaning, and they craft responses based upon the meaning of things. They change their genetics, their phenotype, and their physical form. They perceive electromagnetic fields, the canopy of trees and things. They're catching all this information and processing it and making sense. God! I mean, we're just surrounded. We sometimes think we're the guys, and we're the only ones that are carrying on like this. We're not. They're all over the place. They engage in highly interactive social interactions with their community. It's just giant kind of systems underneath, and they're just like ours. And then it gets worse, because what you then find out is all life forms are in a potential genetic contact, and genetic exchanges between them are going on all the time. And what essentially is that all species have the ability to communicate at different levels between themselves and among themselves. And so there's stuff going on all here across species and up and down and all over the place. And again, you might think that's far-fetched and crazy, but man, I've heard the stories and watched the people, and there's just no doubt about it. Where the deer talk to to the horse, and the horse then tells somebody, you know, and on, and it just seems crazy at first, but then you figure it out that it really works. And so James Lovelock, famous guy, said the entire range of living matter on the earth constitutes a single living entity, capable of maintaining the Earth's atmosphere to suit its overall needs, and endowed with faculties and power far beyond those of its constituent level. So it's the aggregation, it's the integrated kind of system. And what he says is this whole planet is an all one big system, and we're all here to help keep it going. That's what it is. That's really what it is. And that we're all parts of this whole kind of system that help maintain the atmosphere, and everything within the self-organized sort of system, even every part that includes us, is subordinated to the homeodynamicist maintaining self-organism. How do you keep the thing alive and stable and balanced? That's the idea. And so everything on the planet, including us, is all part of the system that's trying to keep the whole thing balanced and the whole thing going. And so then you back yourself into saying, well wow, what? So why have all of these things happened to human beings in the past? And why are we in the middle of this transition to a new thing? And it's all because it's part of the, not just evolution of ourselves, it's the evolution of the planet. That it's all interconnected, and we are all supporting it, and we're all part of that whole thing. And it's all, you know, and we're being shoved and maintained and encouraged and whatever it does in different kind of ways in order to make the whole complex system go.